Hey guys, welcome to CodeChef's YouTube channel. The problem that we're going to discuss today is team formation. The problem appeared in August 21 Cook-Off and is a difficulty level of cakewalk. There are no prerequisites to solve this problem. The problem statement goes as follows. A programming competition will be held in Chef's city which only accepts teams of size 2. That is, each team should consist of 2 people. Now there are some conditions given, that is, at least one person in the team should know programming language and at least one person should know the English language. Also, it is given that it is possible that one person in the team knows both, that is the programming as well as the English language. So the qualification then of the other teammate is not important. If one of the person knows both the things, then the other person does not matter. Like, it is important to have the second person, but his qualification does not matter. Now, given that chef has n students, he wants to send maximum number of teams to the competition. So the information about the people is given to us. That is, first of all, the number n will be given. That is the total number of students. After that, for each student, we know that a binary string is given denoting whether he knows programming or does not know programming. So the first binary string is for programming, binary string S, and the second string is for English language. So I am going to write ENG. So each binary string, 1 denotes that the person knows programming and 0 denotes does not know programming. Similarly for English language as well. The question is, we have to determine the maximum number of teams that chef can form. So we just have to report the maximum number. That is, if chef can form 4 teams, we have to output the number 4. So let's see this sample example. So here there are total 7 people. Some of them know programming, some of them know English, some of them may know even both, and it may also happen that some of them don't know either of them, that is programming and English both. But such case is not present in this given sample. So here the answer comes out to be actually 3 teams. That is, we can form at max 3 teams. One way to see that is that I can pair up person 1 with person 2 because this person knows programming and this person knows English. So they both can be paired with each other. Secondly, I can pair person number 3 with person number 5 because one of them knows programming, one of them knows English. And after that, the third team can be of person 7, and with person 7, the other person whom I choose, it does not matter. Why? Because person 7 himself knows both programming and English. So I can, let's say, pair up person 6 with person 7. So this is one way of pairing up, but it does not matter how you pair up. The only thing matters is the final answer. That is, we have to report the number 3. That is the number of teams. So I think now that the question is clear, we can move forward with the solution approach. The solution approach goes as follows. We can categorize the people into briefly 4 categories. First one is the person or the people who know only programming. Second one is the people who know only English. Third category is the category knowing both, that is programming as well as English. And there is the fourth category of people who don't know any of them, that is neither programming nor English. So we can easily count the total number of people. Let's say the counts are as follows, something like X, Y, Z and W. So we can find the answer only using these counts. Why? Because again we are going to apply a greedy strategy. Because the pairing up is going to be greedily chosen by us. Now why greedy approach works? If you want the formal proof, you can read the text editorial, but I'm going to provide an intuitive kind of approach that I used to reach to the solution. So first thing to note is that the person who knows both programming and English can be paired up with anyone. He can be paired with either the people knowing English, with people knowing only programming, or people knowing neither. It does not matter because the one person is definitely satisfying the qualification. So that is one thing. Other thing is that the person who is knowing only programming, he can be paired up either with the person knowing only English or the person knowing both. But the second case was already discussed with us, so that will not consider here. So the pairings will kind of look like this. Either there will be a pair between the person knowing only programming and only English, or the pair will include at least one person knowing both. So this is going to be how the pairings are going to look like. Okay, so either the pair will consist both only programming and only English people, or it will contain at least one person who knows both programming and English. So if this is the pairing going to take place, then definitely we will save these people, that is the people knowing both English and programming, for the later calculations. Why? Because it does not matter whom we pair them with. So first we will handle the pairings on the left hand side, that is these ones. So first we will form the pairs using X and Y, that is the number of pairs will be definitely minimum of X comma Y. So these many pairs will be formed, and definitely one of them will become zero. Both of them may also become zero, but one of them will definitely become zero. Now what we do is that on one side we keep Z, that is the uh, people knowing both programming and English, and try to pair them up with any possible person. That is, if I write it in this way, on one hand we have people knowing both. So let's say the count was X, Y, yeah, it was Z. And on the other side, we have only programming people, plus we have only English people, plus we have people knowing neither. So does not matter whom we pair it with, this will be the total count. So minimum of Z, whatever this sum is. These many teams are also going to be formed. So after these teams are formed, uh, only thing remains is the pairing between both and both. That is also possible, right? That is, in the team, the first person also knows both programming and English, and the second person also knows both programming and English. So in that case, whatever is the pending value of both, whatever is the count, divided by two number of teams will be participating in the contest. So in total, we have how many contributions? In the end, we got the teams by dividing both by two. That is, both the people in the team know both English and programming. Before that, we paired the people knowing both with any other people. Does not matter whom we pair with. That is also one contribution that we have in our answer. And in the very beginning, we paired the people knowing only programming with only English. So kind of a greedy solution that we have over here. You can work out some examples by yourself to see why this is working, because the order in which we are processing it is very important. First, we are pairing up only programming with only English, then both programming and English with any of the person, and then amongst themselves. That is, in the very end, whatever is the count of Z remaining, we pair it with itself. So kind of Z by 2. So these are the three important contributions that are being done to the number of teams that we are making. So this was pretty much the solution. Now let's see the implementation in C++. So the implementation goes as follows. We take the input for n and then the binary strings s and t. After that, we make the counting variables, that is PROG, programming denotes the people knowing only programming, then only English, then both, and then remaining means the ones who know neither programming nor English. Then we have an answer variable and one helping variable min. So I run a loop and count these values for programming, English, both, and remaining. So if both of the bits are set to 1, it means that the person knows both. So I increment the value of both. If SI is set to 1, then I increment programming. Else if I increment English, else I increment remaining. After that, I pair up the programming people with English people. I also remove the counts from the respective variables and increment my answer. This is the first contribution. Second contribution is pairing up the people who know both with all the remaining people. So remaining plus programming plus English. I take the minimum, remove it from both, and also I increment my answer variable. And finally, if there is some value remaining in the both, I pair it up with itself. So in that case, answer plus equals to both by 2. And finally, I get my answer. So pretty easy implementation in C++. This was a cakewalk problem. So the approach was pretty straightforward. Even if you are not very convinced with the proof, which you may find in the text editorial, the solution was quite intuitive and easy to be implemented. Now, I would like to tell you guys about competitive programming sessions, online classes that we have at Unacademy. So you can learn CP from world-class programmers from CodeChef by getting the subscription on Unacademy, where you get features like live classes, recorded sessions, practice problems, and dedicated doubt support. All this uh, in one subscription. And also, if you are willing to buy the same, you can use my referral code Darshan 25 to get instant 10% discount.